Hi, I'm Martha LOUVY and I'm from Group 18. I'll be presenting the periodic table. So, the periodic table is a tabular arrangement of chemical elements that is arranged by increasing atomic number and groups elements according to recurring properties. As you can see from the periodic table, the column of elements from the left to the right, it is called as groups, and groups are numbered from 1 to 18. Group 1 is known as alkaline metals, Group 2 alkaline earth metals, Group 17 halogens, and Group 18 is known as noble gases, also can be called as inert gases. From Group 3 to Group 12, it is known as transition elements.
Elements with a group share valence electron configuration. Elements within a group display a pattern with respect atomic radius, electronegativity, and ionization energy. The atomic radius, or also atomic size, is increases when moving down the group as successive element gain electron energy level. So the electrons are added further from the nucleus. There is less attraction. Each additional energy level is shield the electron. They shield the electron and to prevent it from being pulled towards the nucleus. So the attraction between the valence electron and nucleus is getting weaker. In periodic table, they are also called periods. Groups are called column vertically, so for periods it's horizontally. And yes, there are 7 rows of periods in periodic table. The element atomic number is increases from the left to the right. Also, the element towards the side of the left is metals and towards the right is non-metals. So across a period, the atomic size or atomic radius is getting smaller. So the size goes down across a period. But it is increased in effective nuclear charge, increase in number of valence electron. Also, the attraction force between the valence electron and the nucleus is getting stronger. Next, for ionic size, there are 2, which is size of cation and size of anion. So size for cation, there are smaller than corresponding parent atom. The atom loses valence electron and the number of proton is maintained. So the attraction force between the nucleus and the remaining electrons, they are getting stronger. So for cation, the results in less electron-electron repulsion. It allows the nucleus and the electrons to come close together. And when compared to a natural atom, example sodium Na, and it's compared to a sodium cation Na+, it has a smaller sizes. And for size of anion, it is different from the size of cation. It is opposite. Size of anion is bigger than corresponding parent atom. The attraction force between the valence electron and the nucleus is getting weaker because due to the number of valence electron that is increases, and the electrons are added into the same shell. So the electrons tend to repel with each other. So anion, the gain of outer shell electrons results in decreased attraction between the nucleus and the remaining electrons. So the electrons repulsion forces them to be spread apart from each other. So compared to a natural atom of fluorine and fluoride ion, it has a larger atom.
Electronegativity is a measure of the tendency of an atom to attract bonding electrons to itself when it is in a molecule. Valence electrons of both atoms are always involved when those 2 atoms come together to form a chemical bond. Chemical bonds are the basis for how elements combine with one another to form compounds. When these chemical bonds form, atoms of some elements have a greater ability to attract the valence electrons involved in the bond than other elements. Electronegativity differs from electron affinity because electron affinity is the actual energy release when an atom gains an electron. Electronegativity is not measured in energy units, but instead a relative scale. Electronegatives generally increase from left to right across a period. Alkali metals have the lowest electronegativities, while halogens have the highest. Electronegativities generally decrease from top to bottom within a group due to the larger atomic size. Electron affinity: the amount of energy released when an electron is added to a neutral atom to form an anion. The more negative the electron affinity, the greater the tendency of the atom to accept the electron. Electron affinity increases going left to right across a period because of increased nuclear attraction. Going down the group, the electron affinity should decrease since the electron is being added increasingly further away from the nucleus. Electrons become less tightly bound and can be easily removed.